Hello and welcome to a live tune. This is a machine that I have reset to factory so that we can walk through a full tune. So I'm plugged in. This is what the factory settings would look like. So I have another camera going. Hopefully I can figure out how to make these jive together. So I'm going to lift up slowly. Just show off what's bad about this. A little higher. Okay, I'm just gonna demonstrate. I let go, still moves. Let go, still moves. I'll tilt back, it's kind of rocking, bumpy. Just not overall, doesn't sound like it's happy. So what we're gonna do first thing, immediate first change we want to do, dial back our minimum PWM on the tilt dump. We're gonna put it to 42. We're going to limit the max to about 72. Actually, we're going to start at 76 just to see how it goes. Now that we've got that, we're going to test our min. So that's when we're going to get hydraulic flow at the lowest position on the joystick. So the minimum position before it starts doing something. So right there. So what we're looking at on the bucket view is minimum power. Okay, I'm gonna tilt back. Now I'm gonna dump it at full power. I let go. Okay, so that in and of itself stopped the momentum from the tilt dump, but we're gonna do one more thing, and what that is we are going to ramp down the positive slope. So it's sitting at 150 over 120. We're going to change that to, we'll start with 100, and we're going to change the negative to 150. In effect, what this is doing, this 100 is the slope, and so the bigger the number, the bigger the slope. And this positive slope percentage per second is basically how fast it's going to ramp up from your minimum PWM to your maximum. So if you have this set to something like 200 or 250, you're going to get a super snappy response. Whereas if you have it at 100, that's about the normal level. And so that one, you'll get soft engagement. It's not lugging. And then that 150 on the negative slope, that's sharpening the slope down to shut the flow off. And so when I let go, it will stop immediately. Now, I'm actually going to turn that 100 up to about 125, test it, and see how I like it. Yeah, I like that a bit better. Another thing I'm going to do, actually I forgot to do this, is increase idle RPM to 1000 RPMs. Should have started with that. That's your starting point for minimum RPMs to actually get a feel for what the machine's going to do under load. So tilt back, now I'm going to slowly dump. Let go, it's good. It's nice and slow, full speed, and I let go and it stops moving. So basically you know you're good with your tilt dump cushion slope percentages if the speed is where you want it and it stops when you want it to. Now I'm going to limit this to about 74 and try it at full speed, see if it lugs. Much happier. I'm going to dial that back to 72. Yeah, the machine is quite happy with that. So typically I run about 40 to 70 or 80 as far as the tilt dump PWMs. The tilt back is usually okay. You can leave this at 50, 45 is okay, 55 is okay. I wouldn't put it any higher than 60 because then when you get a combination command like you want to lift and tilt back at the same time, if your minimum PWM is too high on either side, it will limit the other. So if it's prioritizing tilt back at 60% and the lift, if we go into lift here, So if we're raising at 50 and we're tilting back at 60, well, that means we got 110% demand, and we can't have that. So just something to keep in mind. I'm going to pop back into tilt parameter here. Now, let's try this at 100. That made it even worse. Okay, so we're just going to try it at 200 now, just to see. Yeah, 150 seems to be a good spot for that. Try this down at 68. Okay, let's try 70 as a middle ground. There usually is a happy spot where you'll hear it working the motor a little bit less. Just for the sake of it, we'll crank it back up to 100 just so you can see the difference. So even that at 100% speed with the tilt dump cushion adjustments, it's a little bit more well behaved, but still at 100% it's just too fast. Let's test 84. This is over the top. I normally wouldn't run this many tests. I kind of have a set system, but this machine is actually not going too fast. So I'm going to limit this at 80, give it one final go, and I'll probably leave it there. You know what? I think 84 is better. Okay, so that's good. I'm going to leave that. Now to demonstrate another parameter in here, we have our tilt back cushion here. So this is the limit. Now this PWM for minimum velocity, that is the stopping point when we rack back the bucket all the way. So as I come back, you'll see it slow down right there. And then it comes back and rocks. If you want that cushion to go away, just increase the minimum PWM higher than the minimum that's set on the tilt back current set. So we'll demonstrate. Coming back, it shouldn't slow down. See? Rocks all the way. Engagement is a little bit more aggressive, obviously, but I will leave the cushion in it, so we're going to set that back to 45. And I'll just show how that works one more time. So all the way back, full speed, slows down, catches its point. Okay, so there's that. The positive slope, I usually change this to 125. This is for your tilt back. So this is the same effect as these tilt dump cushion slope percentages, but just inversely for the tilt back. Little trick is, if you want more of a flick, like that snappiness right there, like in a gravel pit, they want to flick the gravel into the back of the bucket, and so you would increase this to about 150 for more flick. 100 would be less flick. And 200 would be the most. 250 I've even done, or rather 225. So if you wanted a little bit of a softer engagement for the tilt back, set it to 125. Then it's still snappy, but it's not overt, and it's not causing the machine to bounce, you know, just off a simple tilt back. So that's the basics for the tilt. For lift, very similar. I'll demonstrate one problem I found. I'm going to auto auto lift all the way up to the top here. And sometimes what I notice is that on the lower or a return to dig, it's too fast. So here we go. So that's my manual, just full throttle down. Now I'm gonna auto lift again, and then what I'm gonna do is use the return to dig function, and I'm gonna see how fast the speed is on the return to dig. So here we go. Okay, so that speed is not too fast. That's perfect. If I wanted to limit that, I could change the proportional max PWM for auto lower just by simply pulling 10% out of it, 20%. You just need to go lift it, return to dig, and just keep trying until it's at a speed that's acceptable. This one's not bad, but some of the ones from the factory, they're a little bit aggressive. Now into our lift. Same rules apply for the tilt. Your min PWM and your max PWM. This min PWM for your lift is the slowest speed it will go, and then when I pull it all the way back, now we're at 100%. So let's go back down. So this would be 50, this is 100. It's hard to tell, but you can feel it very obviously in the machine. Okay, so you can do the cushion adjustments for the lift and the lower as well. Don't really mess around with it. If you're going to do anything, you can turn this 130 into a 100, or these 100s into a 125 or a 130, and see how it responds. Like I said, the higher the value in these slope percentage per seconds, the faster the engagement and disengagement. So makes it a little bit more violent. Lowering these numbers makes it much more smooth and controlled, and ultimately more comfortable to operate. The last thing I'm going to touch on in this is going to be quick tests. So this arm angle and this tilt angle, if these are ever starred out, you've got a sensor installed upside down on the boom angle or the bucket angle. If your operate mode switches from manual into fault, same deal. These will likely be starred out at some point in the lift and lower, tilt and dump cycle. And it's simple as flipping up that switch, or sorry, removing that sensor and flipping it upside down, reinstalling it. Another quick thing, really helpful, I/O diagnosis over to digital input. I always test the fine control and the tilt follow switch, because those are also what goes out when we have a sensor installed upside down. So all I'm doing right now is I'm flicking the switch, and as you can see, my tilt follow switch just enabled, and so that means that switch is functioning. I'm going to disengage it. Now I'm going to do the fine control. Fine control's working. Switch it off. Good. So that is